Hello there guys, in this video I'm going to talk you through how to do enlargements, and I'm going to start off with just positive integer scale factors, but if you look at some of the later videos later on there will be explanations of how to deal with fractional, negative and then fractional and negative scale factors too. So first of all I just want to explain the idea of enlargement. The idea of enlargement is everything is either expanding or shrinking away from a certain point. And the effect of that is all the lengths will multiply by a certain number, but also the distances of every single point from that center will also multiply by that same number. And to start off with, I find it a really good analogy is imagining space kind of expanding. Now, I apologize to any astrophysicists if this is technically not correct, but I imagine having some kind of central point in the galaxy, which I've labelled here as O with an X, and then I've got some stars around. I've been a bit cheeky doing stars because normally it's easier if we have one defined point. So I've got a few different coloured stars, and what I'm going to imagine is these stars are expanding as the galaxy expands, but they're all moving away from the O, from that origin point O. So the stars are all travelling in a straight line away from it. So for example, this one here is travelling away in that direction, but this orange one up here is travelling away in that direction. So all the stars are travelling directly away from the origin point O. And because we're going to do a scale factor of 2, they're all going to end up twice as far away from O that they started. So we're doing scale factor 2 for this one. Okay, now the first method I'm going to show you involves drawing what we call ray lines. So rather than making you sit and watch me do that, I'm just going to pause and do them now. Okay, so what I've done is I've drawn my first ray line really carefully with a ruler, going from the origin O, the centre of enlargement, to one of my stars. And I've measured the length as well, and it's 4.5 centimetres exactly. So what I'm going to do is I'm going to times that length by 2, and I'm going to draw a line from O going through that, which is twice as long. So 4.5 times 2 is 9. So what I need is a line that starts here, goes through that pink star, so it goes along that line I've already drawn, but is 9 centimetres long rather than 4.5. Okay, so what I've done here is I've continued my line on an extra 4.5 centimetres, so I now have a length of 9, and you'll notice that if I now pop the pink star down at the end of that line, it should now be twice as far away from O as it started. And I'm going to do exactly the same thing for all of the other stars as well and see what we end up with. Okay, so what I've done now is I've drawn ray lines going from O to each star. I've measured each length, so I've got 2.7, 4.8 and 6.5. And then what I've done is I've times each of those numbers by 2, and I've drawn a line twice as long. So I've done 5.4, I've done 9.6, and I've done a 9, and each, a 13. And for each one, I've done it from O through the original point and kept going. Okay, so now what I can do is I can draw my new stars, and every one will end up twice as far away from O as if it's just been traveling in a straight direction away from it, okay, as my universe here has expanded and doubled in size. So what you'll notice is, as this has happened, the points have been traveling away from each other as well, okay, and actually if you measure, for example, this length here from the blue to the orange star, you will find that the new blue and orange star, where they've ended up, that length there has actually been doubled, okay? And this is a method that will allow you to enlarge shapes. So I'm just going to draw a shape around each of those original and end points, and you'll be able to see how the shape lengths have doubled in size as well. Okay, so what I've done for you is I've drawn around my original 4 stars in blue. That is my object, my original shape that I could have started with. And I've then drawn around my 4 transformed stars after they've been enlarged. I've drawn around those as well, and I've done those in red here. and that makes the shape that's my image, so after the transformation has happened. And if you look at those two shapes, you'll notice that they look very similar. They are actually mathematically similar, which means all of the angles in them should be the same. So, for example, this angle here should be the same as this angle here, okay? And this angle here should be the same as this angle here, and the same for the other two angles as well. And if you were to actually measure the side lengths, you will find that each of them has times by 2. So this length doubled will get you this length. Okay, so when you enlarge shapes by a whole number scale factor, what you need to know is the center. You need to then move each corner or vertex of the shape, okay, away, so it's this times as many far away from that center in a straight line. And once you've done that, you will end up with the correct points to join up for your image. Now, you can do this using the ray lines method, and it will work absolutely fine for you as long as you're very, very careful being accurate. It's fine if that method consistently works for you and gets you the right answer. I'm going to show you an alternative method, first of all, which gives you exactly the same answer, and it's actually doing the same thing underneath, but I like it because it guarantees that you get the right answer, even though it takes a bit longer. And I also like it because it gives me the chance to show you a bit of notation as well. And this is a method which works really nicely for negative and fractional scale factors later on. So even if you don't love this method right now and you feel happy with the other, I'm going to suggest that you watch and have a go at it so that you can then use it when you get onto more difficult questions that the other method might not work so well for you for. Okay, so here is an example of a question. So we've been given a shape and we've been given it on a set of coordinate axes, okay, and we've been asked to enlarge the shape by a scale factor of 2 with a center of enlargement of 0,2. So the first job whenever you're faced with an enlargement is put that center of enlargement clearly on the picture. Now, I hope I don't have to say this. A lot of people get it wrong though, even though they know exactly what they're doing. A lot of people pop the center of enlargement on by swapping the coordinates around. So just be really careful and take your time when you do that because you don't want to make a mistake with that. So 0,2 is 0 along, 2 up. That's here. So that is my center of enlargement, which I'm going to call O for present purposes. Okay, now to do my method that I'm going to show you is a little bit long-winded, so you don't have to do this every time, but I just want to show you for the first one. I'm going to name 3 of the vertices on my shape. So I'm going to label this one here A, I'm going to label this one up here B, and I'm going to label this one down here C. I could do all 5 if I wanted to, but I'm not going to for the moment. I just want to show you with 3. When you get confident with this, and if you do like the ray lines method, what you might want to do is just do this with one of them to position your shape before you start. So what I'm now going to do is I'm going to think about the journey from O to each of these points, and I'm going to write them as column vectors. Now, a column vector, in case you're not too sure, is when we write the journey as a certain number going across and then a certain number going up or down. So, for example, if I wanted to go from O to A, and I write that because it's a journey, I put a little arrow above it, so I'm showing going from O to A. If I want to do that by going across and then up, I would have to go 3 across and then 1 up. So to say 3 across and 1 up in vector notation, I just write a 3 and then a 1. And I always read across and then up or down afterwards. So it's 3 across, 1 up. I'm going to do the same for O to B as well. So to go from O to B, I have to go 1, 2, 3, 4 across and then 2 up. So I'm going to write that as the vector 4, 2. And then finally, to go from O to C, I've got to go 1, 2, 3, 4, 5 across and 1 down. So I'm going to have 5. And then to show I'm going downwards, because I'm going down the number line in the negative direction, I'm going to write a -1. Okay, so 5 minus 1. So those are the 3 original vectors to take me from the center of enlargement to 3 of the vertices. What I'm now going to do is I'm going to double those journeys. Okay, and those of you who want a bit of technical language, when I multiply a vector or a journey by a number, we call that a scalar. Okay, scaling something up. Okay, now in order to work out what that scalar is, what that multiplier is going to be, I just use the scale factor. So because we've been told for this question that we're going to do scale factor 2, the number I'm going to be multiplying by is 2. And I can use that to work out the journey from my origin, from my centre of enlargement, to my new point that I'm going to end up at. And in order to talk about the new point, I'm going to use the same letters, but I'm going to put a kind of apostrophe dash afterwards to show it's the new version of it. So I'm going to go from O to new A, or A dash. I'm going to go from O to new B, or B dash. And I'm going to go from O to C dash. Some of you might want to pause the video now and have a go, or maybe watch me do the first one and then pause and have a go. So all I need to do is I need to times this vector here by 2. So going 3 across and 1 up, doubled, is 6 across and 2 up. All I'm doing is timesing both of these numbers by this number here. For the next one, I'm going to get 8, 4. And for the last one, I'm going to get 10 minus 2. Okay, so you must remember at this point that all of these journeys are starting here. As long as you remember that, you will be absolutely fine for the next step. So now I'm just going to plot where I end up at the end of each of these journeys. So I start at O and I go 6 across, 2 up. So from here, 1, 2, 3, 4, 5, 6, 1, 2. So that point is now twice as far away from O as A was at the beginning. So that's my A dash. Okay, and I do the same for the next one. 8 across and 4 up from here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. That's my B dash. And now I'm going to do my C dash. So that's 10 across and 2 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. Okay, so those are the new points for my shape. And if you've done enough, you should find that you can now draw the shape on correctly. So I'm going to do that with a dotted line first of all, and then I'll go over it with a ruler once I've checked it. You would, of course, do all of this in pencil, but I can't because you won't be able to see it for myself. So from A to B, I should have a line that goes kind of diagonally, and then it goes diagonally down the other way. If you're someone who finds it hard to visualize this, you can just do the method for that point too, which is absolutely fine. Then we go straight down in order to get to C, and then we go across and up to form the rest of this kind of rectangular-y bit. So that is what my shape should look like. Okay, now if I've done it right, 2 things should happen. First of all, each of my lengths should have been doubled. So this length here, that was a length of 2, has become a length of 4, which is good news. This length was a length of 2, it's now become 4. This was a length of 1 diagonal, it's now become 2 diagonals, so that's looking good. The other thing that should work is if I go from O to my new point, the old point should be on that line. So if I go from O to A dash, you can see A is on that line. If I go from O to C dash, C is on that line. And if I go from O to B dash, B is on that line. So I know that I'm on the right track. And you can even do it with the ones that you haven't actually labelled. So if I want to go to that bottom corner down there, the bottom corner of the other shape should be on the line as well, and it is. Okay, so you can kind of check with the ray lines. You can do this method just using the ray lines, but the reason that this is as a kind of checking mechanism is really good, even if you don't use it, is that when you do the ray lines, you have to be careful to be accurate, because you're going to often get decimal values, and sometimes people go slightly off and don't quite put things on the right places when they do this. So that's why I encourage people to do at least one of these vectors just to check that it works out the same. Some of you, when you get really confident with this, will be able to look at it in your head and think, right, 3 across, 1 up, double that, 6 across, 2 up. So you're thinking about vectors even if you're not necessarily writing it all down. Okay. Here's another example. So job number 1, put the centre of enlargement down. 1, 3. I'm going to do this one using the ray lines method. So I'm going to start by doing a ray line for this point here that I'm calling A. Then I'm going to do this point here that I'm calling B. Then I'm going to do this point here that I'm calling C. Okay, so I've drawn a straight line from the centre of enlargement through A and kept on going. Because it's a scale factor of 3, I need to times the length by 3. Now, the distance from my centre to point A, I'm going to measure carefully, and that comes out for me as 4.4. Okay, so 4.4 centimetres. I need to times that 4.4 by 3. So that becomes 13.3. So what I need to do is go from here 13.2 centimetres along this line, and that's where A is going to end up. So 13.2 along that line gets me to here. That's my A dash. Okay, I could do the same method now to find out where B ends up and where C ends up. But you have to be really careful if you do this method to be accurate with your numbers, because you will have decimals coming in. Okay, so what I've now done is I've drawn my ray lines going from the centre through B and carrying on, through the centre, through C on carrying on. I've measured them. I've got 10.1 and I've got 7.8, and I've times them by 3 as well to get 30.3 and 23.4. And when I do that, the points I have to end up at is for C down here, and for B, up here. Okay, you have to measure them carefully, but most of the time you are going to find, particularly for integer scale factors, that you end up on a cross on the grid. So just make sure that you're at an exact point and that your numbers match that. Once you've done that, all you need to do is join up your points, and you should find that those lengths have doubled. Before I do that though, I'm going to check by moving one of my points using the vectors method as a way of checking. And I'm going to do that using O and B. So I'm going to look at the vector from O to B, and then because my scale factor is 3, I'm going to be tripling my vector using a scalar of 3. So to get from O to B, I have to go 1, 2, 3, 4, 5, and 2 up. So 5 along, 2 up. When I times that by 3, I get 15 and 6 up. So if I've done it correctly, going from here to my new B point, I should go 15 across and then 6 up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6. So I know I'm correct, and you can test other points if you want to, just to be completely sure. Okay. One other thing just to point out before we move on, and I will do this in red even though we're going to start having a lot of lines on, is you'll notice that this vector 5 across, 2 up can be done 3 times to get to our point. So that journey, you can see, happens 3 times instead of just the once. Okay, so I've now joined up my 3 new vertices to do my image, and I'm happy with this because my image is similar, mathematically similar to my original shape, my object, but the lengths have been doubled. You can check that if you want to with a ruler just to make sure you're happy with it, but you should also find that the angles remain the same. So for example, this one here at C is in the same place, is the same size for C dash, and the same for the other 2 angles. So when you do it correctly, angles will be the same, lengths will be multiplied by the scale factor, any ray lines should go through the centre of enlargement, the original angle or vertex, and the new one. And you should also be able to make the vectors work with the scalar of the scale factor. So there's loads of little things that need to happen, and you can use to check your answer and be really confident with it as well. Okay, so that's how to do an enlargement by a positive integer scale factor. Even if you are really, really confident and you can do these visually quite easily, I would encourage you to keep all those tips and tricks in mind and maybe practice them for easy questions, because people do find the negative and the fraction enlargements that we need to see later on in the topic more difficult. So if you've got these kind of tricks and methods of checking, that will help you a lot when you come to do these later on.